seed-transmitted viruses are very important in vegetable production worldwide. We know very well that bacteria, fungi, and viruses and viroids, they transmit it from by seed. And the question is why seed transmission, which is called also vertical transmission, is very important. First of all, presence of the virus is within the crop at an early stage, which means the crop is very susceptible to virus infection. The second one is that we do have randomized foci of primary infection, mechanical or through vector. Therefore, the virus sources are inside the field. And the other very important thing is, at least with some viruses, virus longevity in seed is very long. You can see here, for example, BCMV, squash mosaic, tomato mosaic, which is not very important at the moment, but we do have another tobacco virus now. CGMMV, a very important cucurbit viruses, and pepino, the last 20 years, they stay in the seed for a long time. And also you can see that many viruses, seed-transmitted viruses, they cause very high yield losses. You can see for big common is almost 100%. Big yellow mosaic is 60%. Broad bean stain is between 14 and 61. CMV in lupin is 25 to 42%, and so on. Now, we know very well that there are many different biological characteristics of seed transmission. First of all, seed transmission depends on the cultivar. So we have some cultivars which show very high seed transmission rates, and we do have some cultivars which show very, very low seed transmission, or in some cases, no seed transmission at all. Also, the virus itself, the virus strain, is very important for seed transmissions. So we do have strains which are very, very easily seed transmitted, and we do have others which are not transmitted by seed at all. The other thing is that seed transmission rarely reaches 100%, usually is less than that. Fourth, seed transmission efficiency is influenced by the age of the mother plant when it is infected. So if the plants are infected early, and we mean early before flowering, then the rate of transmission, seed transmission, is very high. If they are infected after flowering, then seed transmission is really very low. And finally, in most cases, the embryo is infected with the virus, but in few cases, the virus is externally attached to the seed. So we know very well that we do have two types of seed transmission: externally on the seed coat, and this happens with viruses like tobacco, and then by mechanical inoculation, the virus is transmitted to other plants, and embryo transmission, which is actually called true seed transmission. This happens before fertilization in direct mechanism, gametic transmission, and after fertilization by direct transmission. Now, let's see whether virus infection cause any symptoms on seed. The first thing is that diseased seed is less viable and therefore has low germination capacity and reduced vigor and may show some morphological changes. This is not the case with all viruses. Some cause symptoms to the seed, some others, they don't. Effect of virus infection on seeds. Seeds in general are vehicles for the distribution and dissemination of plant pathogens and new pathotypes. If we import in our country virus-infected seed, then you may have a new virus or we may have a new virus strain. Also, seed-borne pathogens are sometimes the causal agents of disease outbreaks, since very small amount of seed-borne inoculum can be of major epidemiological significance. Seed-borne plant viruses and viroids. We know so far that about 230 seed-borne viruses and viroids infect plants. Internationally traded botanical seed is a pathway for introduction. And as we import, for example, in Greece, almost all the vegetable seed, we also import very many viruses, seed-transmitted viruses. And now I will explain you, I will show you an example. Australia imports most of its tomato, capsicum, and cucumber seed. Therefore, in tomato and capsicum, we have different viroids, and in tomato, we do have a serious pepinomosaic virus. This is a new virus which appeared in tomato the last 20 years. And also, in cucumbers, we do have CGMMV, which cause very serious problems in different species of cucurbits, and of course, melon necrotic spot virus, which is also very important in cucurbits. Therefore, I will show you some case studies of seed-transmitted vegetable viruses. The first one is CGMMV on the left, you can see, which is very, very important cucurbit virus. The other one is, as I told you already, is pepinomosaic. Pepinomosaic started as a pepinovirus, and the last 20 years, it shifted to tomato. We do have also a new tobamovirus in pepper, which is pepper mild mold virus, which is also transmitted mechanically. All these viruses, actually, CGMMV, pepinomosaic, and pepper mild, are only transmitted mechanically. They don't have any vector. And finally, this is rather an exception, TYRCV. It was shown recently that is also transmitted by seed. Whether this is the case, we don't know yet. Okay, let's start with CGMMV. CGMMV is a rather very old virus. Its first report in UK is from UK, from England, in 1935. And now you can see in this chart worldwide distribution of CGMMV between 1935 and 1986, almost half century. The virus was found only in 14 countries. Then from 87 up to 206, 29 years, 15 more countries were found with this virus. And recently, the last 9 years until 2016, 13 more countries found with this virus. Therefore, it seems that recently the virus is almost widespread everywhere, and this is because of the seed. Now, let's go in Australia. First report in Australia was in August 2014, and that was in watermelon, squash in Northern Territory. And very, very soon, they had further outbreaks have been recorded. April 15, next year, in Queensland, May 16 in Western Australia, and May 17 in Queensland, cucumber. And what is very, very important is that the origins of these infections is considered likely to have been imported, and how they have been imported by seed. CGMMV invasion in Australia, and you can see here in cucumber, number of positives, 1, 86 here, 7, 8%, in melon about 16%, in pumpkin 0. So it seems that the virus was imported with seed of cucumber and melon. Sorry. And imported seed from October 2014 and December 16, they tested many seed lots by ELISA. And ELISA, it was found that ELISA, of course, is less sensitive than PCR. And seed type affects the ELISA and PCR results. They also had false negative results. This is how CGMMV was imported in Australia. You can see here 2.3% of the tested seed lots were positive. And here you can see CGMMV symptoms in different cucumber plants. You can see here mosaic in the fruits, mosaic in the melon, and CGMMV is almost a disaster in watermelon. You can see the plants, they produce almost normally, but the fruit is not for commercial use. Symptoms on cucumber: stunting, leaf mosaic, leaf mottling, and the most important for the farmer, fruit malformation and mosaic. You can see here very severe symptoms in the top leaves here of cucumber. But CGMMV is the major problem in watermelon crops. All of you, you know that now watermelon is grafted on the different rootstocks in order to control fungal disease, for example, fusarium. And because of that, they use different rootstocks. And if the rootstock is CGMMV infected, then the plant, the watermelon plant, will be also infected. And you can see here the symptoms on the leaves, and also the fruit is the flesh of the fruit is deteriorated. You can see here the fruit is unmarketable. You can see here the maturation is incomplete. And also there is a necrosis in the petiole. And of course, a very, very severe yellow mosaic symptom on the leaves. And you can see here how the virus, you can see monitoring the spreading of CGMMV in cucumber in greenhouse. As I told you before, CGMMV is transmitted mechanically. So the farmers, because they don't know how the virus is being transmitted, they can transmit the virus to the whole greenhouse very, very quickly. So you see the monitoring of CGMMV in the crop. And now, which are the reasons for increased worldwide distribution of CGMMV? First of all, long-distance dispersal around the world being facilitated by the trade globalization. As I told you before, for example, in our country, we import almost all the vegetable fruit. That means if the seed we import is infected, then we import a new virus. Seed companies produce seed at reduced cost in developing countries. And in this case, there is a high risk of crop infection by seed-borne viruses. Such dispersal is being also exaggerated by ever-increasing agricultural diversification, intensification, and of course, the other thing is relaxation of national plant guarantee regulations. And therefore, in many countries now, CGMMV is an important virus disease of cucurbits. And the thing is, these viruses, like tobacco viruses, they stay in the greenhouse, they stay in the soil, the trees for many, many years, for a long time, and they stay also to the greenhouse infrastructure for a long time. So the greenhouse itself is also a virus source. And now we move to the distribution history of another very important virus the last few years, which is pepino mosaic virus. The first report of pepino is Insulanum muricatum in Peru in 1980s. And after 25 years, it was a host jump to tomato. So the first report was from Holland in 1999. And now, what is very interesting, the virus has a worldwide distribution in tomato crops. And this is because, again, of seed transmission. Now, you can see the distribution of pepino mosaic, and we know now 45 countries, they have pepino mosaic a problem in tomato in about 20 years. And the virus is moving on because of the infected, because of seed transmission in tomato. You can see the symptoms: yellow mosaic or milder mosaic. You can see here a typical mosaic in tomato, like most Tobamo viruses. This is not a Tobamo, this is a Potex virus. And you can see, of course, the symptoms in the fruit. Now, again, in the case of pepino mosaic, we do have a long range and short range dispersal of pepino. I have already mentioned contamination seed, although is a very, very low efficiency. Even this efficiency can cause very high yield losses. In the national seed trade or by seedlings, also is a good way of virus transmission. And of course, via tomato fruits. Now, moving on to pepper mild mode. The first report was in 64 in USA. The virus was officially named in 84, and now there is a worldwide distribution in pepper. As you can see again with pepper mild model, the virus now is everywhere where pepper is cultivated. It causes very, very mild symptoms in pepper leaves, but it causes very, very severe symptoms in pepper fruits. And of course, this is a disaster because the fruit is unmarketable. We do have this virus in the greenhouses, and we do import almost every year a new strain of this important virus because of seed transmission. Also, you can see here different symptoms in different pepper cultivars. And last example, which is a rather exception, we do, the virologists, we did know that viruses like begomoviruses, like TYLCV, I'm pretty sure that TYLCV is present in Pakistan. They are not transmitted by seed. But in 88, it appeared a new paper saying that the tomato yellow leaf care, a whitefly transmitted virus, is also seed transmitted. Worldwide distribution of TYLCV. TYLCV is almost everywhere. This virus is transmitted by Babesia tabaci, is persistently transmitted. At the beginning, it was thought that this virus is not seed transmitted. TYLCV symptoms are very severe in tomato, and actually the plant, they show leaf curling, yellowing, and so on. And the plants, if they are infected very early, in the growing season, they don't produce almost any fruits, or the fruits, they are very, very small. And very, very recently, in 2018, a new paper came out saying that tomato yellow leaf care is a seed transmissible Gemini virus in tomato. Therefore, it seems that seed may also a way of importing this virus in many, many countries, and also in our country. Sweet pepper is an asymptomatic host of TYLCV, and seeds infected with TYLCV could also act as a silent source. Now, okay, we know pretty well that we do have some very important seed-transmitted viruses. How we can test that the seed is virus-free and healthy? The best way to do that is by growing on tests. Although this is very valuable method, it's not very easy to do that because we need a lot of space and we need a lot of time. We can also use DAS ELISA, and we also use PCR, real-time PCR, and so on. From the methods we are using now, PCR are either conventional or real-time, are more sensitive than ELISA in testing the virus in the seed. And moving on, how we can manage the seed-transmitted viruses. We do have 5 approaches to do that and to manage that. Avoidance of the virus from the seed. How we can do that? We can do that by testing the plants before we take the seed, so we know that the mother plant is healthy. Prevention and minimizing the rate of spread through vector management. This is not always very easy because we know that we do have problems in taking white fly, which transmit TYLCV, for example. But all the other viruses I have already talked to you are not vector transmitted. They are only transmitted mechanically. The third one is legislation. The fourth one is production of healthy seeds through certification programs. So the companies, they should have certification programs in order to produce virus-free seed material. For example, now in Greece, all the imported seed lots are tested for the viruses I have already mentioned. And the companies, they have to produce documents. They have already done so. And finally, we have to use modern diagnostic molecular and biochemical approaches in order to test the seed lots we are planning to use for production. In conclusion, to prevent virus introduction through seed production crops need to be monitored for virus infection regularly. In seed-producing nurseries, inspection and removal of seedlings showing virus-like symptoms will improve the quality of the virus. And you can see here a lot of seedlings nearby, so the virus can move from one plant to the other if we have seed transmission. And finally, the seed industry has a twofold responsibility for seed health: to deliver sufficiently healthy seed to its customers and to respect national phytosanitary regulations. This is my talk. This was about major mechanically transmitted viruses like the CGMMV, pepino mosaic, and peppermint moth. And